Hello everyone. This is our second lecture for Chapter 4, An Introduction to Probability. In this lecture video, we will discuss the different types of probability. There are three ways to arrive at a probability statement: empirical, classical or theoretical, and subjective probabilities. Because probabilities deal with the long-term proportion of a particular outcome observed in situations with short-term uncertainty, it makes sense that we start our discussion of determining probabilities using the idea of relative frequency. Probabilities calculated using relative frequency rely on empirical evidence, or evidence based on the outcomes of a probability experiment. The empirical probability of an event is found through observations and experiments. It is the likelihood that the event will happen based on the results of the data collected. For example, imagine we were to survey a class of 50 students. We ask them to choose their favorite ice cream flavor, such as vanilla, chocolate, mint chip, Rocky Road, cookie dough, and so on. If 15 of the students chose vanilla as their favorite ice cream, then based on these results, the empirical probability would be 0.3. This is an example of empirical probability because we collected data through our survey and our probability is based on the results of these data. Empirical probabilities are used when we do not know all the possible outcomes of an experiment. It's used most often in statistical inference procedures. So how do we calculate probabilities using the empirical method, aka relative frequency method? The probability of an event E is the number of times event E is observed divided by the total number of trials or observations. So the probability of E equals the relative frequency of E equal to the number of times E occurs divided by the number of trials or observations. The probability we get using the empirical method is an estimate because different trials of the probability experiment will lead to different outcomes, and so will produce different probabilities of event E. Take our example of ice cream flavors. In our original survey, we found 15 students who prefer vanilla ice cream. Now, if we were to survey a different group of students, would we get the same probability? Would we get the same number of students preferring vanilla ice cream? Probably not. However, as we increase the number of trials or runs of a probability experiment, our probabilities become more accurate. Again, the law of large numbers. Other examples of empirical probabilities are prescribing medical treatments, determining insurance rates, forecasting weather, and so on. The classical or theoretical method of calculating probabilities does not require you to conduct an actual experiment. Theoretical probability is when you estimate a probability without testing it. It is based on an ideal situation. Theoretical probability is used if we list all possible outcomes of an event and if each outcome is equally likely. A theoretical experiment is considered to have equally likely outcomes when each outcome has the same probability of occurring. For example, in throwing a fair die once, each of the 6 outcomes in the sample space, 1, 2, 3, 4, 5, 6, has an equal chance of occurring. We calculate theoretical probability as the probability of E, a probability of event E, is equal to the number of ways that E can occur divided by the total number of possible outcomes. So the numerator is the number of outcomes in event E, and the denominator is the number of outcomes in the sample space. An example of calculating probabilities using the classical method would be, let's say that we have a fair die, and we want to calculate the probability of rolling an even number. What is the total number of possible outcomes in the sample space? There's a total of 6 possible outcomes. 1, 2, 3, 4, 5, and 6. What is the number of ways that we can roll an even number? The probability of rolling an even number is 2, 4, and 6. 3 outcomes. So the probability of rolling an even number is equal to 3 divided by 6, which is equal to 1/2, which is equal to 0.5. Theoretical probabilities are used in poker, blackjack, and other card games where all possible outcomes are known and outcomes are equally likely. Theoretical probabilities are also used in many areas of science where direct experimentation is not possible. For example, probabilities involving subatomic particles or abstract structures like vector spaces. Subjective probabilities are not based on any real math or formal calculations. Instead, they are based on a person's personal beliefs about the likelihood of an event happening. Since it is based on personal beliefs, it is usually different from other people's subjective probability of the same event. Subjective probabilities are a necessary part of life and are ways to quantify the unknown. They are based on opinions and past experiences. Think of subjective probabilities as ways to make decisions on limited information based on gut feelings or hunches. In the next video lecture for Chapter 4, we will discuss different types of events.